You may have heard the claim, the water existing on Earth now is the same as it existed tens of millions of years ago when dinosaurs roamed the planet. In fact, although the atoms that make up water molecules have existed for eons, dinosaurs probably did not once drink the same water molecules that we consume today. This is simply because matter on Earth, such as water, is never destroyed or created. It is changed and recycled. Unlike the one-way flow of energy, matter is recycled within and between ecosystems. Elements that pass through from one organism to the other in closed loops is called biogeochemical cycles.
These cycles involve biological processes, geological processes, and chemical processes. Natural biological processes consist of any and all activities performed by living organisms, breathing, burning, and eliminating waste products.
Geological processes include volcanic eruptions, the formation and breakdown of rocks, and major movements of matter within and below the surface of the Earth. Chemical and physical processes include the formation of clouds and precipitation, the flow of running water, and the action of lightning. Through these cycles, the elements that serve as the building blocks for life on Earth are incorporated into microorganisms, plants, and animals, and are transformed from organic to inorganic forms and back again at various rates. Some cycles process elements quickly on the scale of a human lifetime or less and result in renewable resources. Non-renewable resource cycles, however, take much longer, operating on geological timescales such as millions of years. A component of a biogeochemical cycle that holds an element for a short period of time is called an exchange pool. For example, the atmosphere is an exchange pool for water. It usually holds water for just a week or two. A component of a biogeochemical cycle that holds an element for a long period of time is called a reservoir. For example, the deep ocean is a reservoir for water. It may hold water for thousands of years. Human activities also play a significant role in biogeochemical cycles. A broader concept of cycles of matter would be the life cycle of human activities such as manufacturing a commercial product or providing commercial services.
As the human population continues to grow and require more resources to fulfill its basic needs, technological advancements usually focus on satisfying consumers' desires, but sometimes neglect their impacts on the environment.
All of the items we buy go through a series of processes before getting into our hands, such as mining for raw materials to make aluminum cans, burning of fossil fuels to produce energy, and the cleaning of land for building and farming. The impacts we are having on the environment are of increasing concern for the future sustainability of the planet. However, understanding how matter and energy travels through their lifetime would help us make better decisions and mitigate the impacts on the environment. Therefore, life cycle assessment, LCA, is widely used to support sustainable development. LCA is a modeling tool to assess environmental impacts related to a product during its entire lifespan, from raw material extraction through processing, manufacturing, distribution, use, and disposal or recycling. LCA can analyze and quantify all emissions to the atmosphere, water bodies, and soil in order to estimate the potential impacts on human health, global warming and climate change, ecosystem quality, and resources depletion. There are standards and protocols that need to be followed while doing LCA, and thus should be performed by professionals. Let's look at a simple example of vehicle's life cycle. First, raw ore is mined and used to make the material of the main part of the vehicle. Then the vehicle is manufactured. Afterwards, the car is sent to the customer for use. When the car exceeds its lifespan, it is sent back to the scrapyard, and some parts can be recycled back into materials again. And then life cycle of cars starts all over again. Throughout the life cycle of the vehicle, the material used, the energy consumed, and carbon dioxide emissions are monitored and analyzed with the LCA model. Okay, that will be all for today. In the next 3 sections, we will take a closer look at some of the particular biogeochemical cycles, including the water, carbon, and nitrogen cycles.